I've brought something.
Yeah?
So I'm here at Microcenter, and you might not realize it, but building a computer where the processor alone costs almost $4,000, that can be a little intimidating. But Microcenter has a build service to help you with that build. And Microcenter is helping me with the launch of the 3990 in terms of let's benchmark it, let's run Linux on it, and let's do all kinds of stuff. But we're here to talk about a little bit, at least, the build service, because they'll help you build it so you don't screw it up, because there's like a lot of pins.
Yeah, a couple.
And like that one that's messed up.
Oh yeah.
That means it
Totally
doesn't
gone.
work. We can fix it. We have the technology. So tell me about the build service.
Basically, if you're not happy with the way a pre-build looks, or if you have something specific in mind, we have an entire department where you can come in, pick out your parts, and our associates will help you do that. They'll get you anything you want. So if you want 128 gigs of RAM, we'll get that set up for you. If you want a couple SSDs, we'll throw them in RAID for you. It'll be brought back to one of our A+ certified technicians, and he'll have it done in usually 1 to 2 hours, depends on what you have going. If it's something like a hard tube liquid cooling, it's
That's going to take a little longer. That probably costs a little extra too.
yeah, a little extra, yeah. But he knows what he's doing. He's probably well over 100 builds at this point.
So what if you're a certifiably insane person like me and you actually like want to participate in the build? Because I noticed there's a huge pile of parts built up behind us.
We'll work out some scheduling, and our techs will do it alongside with you. And
It's a little bit like the secret. Must get ready for the build.
yeah,
So Microcenter.
really exciting.
Turns out that this particular Microcenter, I've actually spent tens of thousands of dollars over the years, probably north of 100,000, maybe north of 200,000, because I got a lot of stuff I got to buy. So I think we've got a build to do. Let's get building. So they've got the bench set up. This is like a geek's smorgasbord, a geek's buffet. So I would have already called in ahead of time and let them know what I was looking for in terms of the build. We've got the $4,000 processor. Obviously, I'm sorry, 3990. We got the 3990 that's 3990 US, which is 64 cores, 128 threads. We got the ROG Zenith Extreme Alpha. This is the new one with the beefed up VRMs for this particular processor. We've got 128 gigs of G.Skill Trident Z Neo, dual Samsung 970 Plus SSDs, tons and tons of Touch Aqua fans. Do you think it's gonna be enough fans?
I think it's going to be enough fans.
Dual EVGA 2080 Ti, the fastest GPUs that you can get right now. We've got the full EK cooling kit. So this is the Dynamic O11 XL case bracket kit thing, which actually this is kind of hard to find.
Yeah, distro plate. Don't see them around all the time,
Yeah.
but we carry them.
That's nice. We get the Dynamic XL case, obviously. EVGA 1600 watt power supplies and dual bits power rads. So things are getting serious. Let's unpack and do a build. I love what they do with the wire management in the Lee & Lee, because you get the dust filters and they cut the little notch out for everything, and you've got the rubber grommets. They really do a lot with all the different, sort of innards.
Yeah, if you've got the space for this case, I mean, especially for the 24 pin, getting that angled grommet really helps out a lot.
So this is the most horrifying part of the build. And by horrifying, I mean it's actually pretty fun. But this is the part where if you're careful, you can do it on your own, but the Microcenter build service, really, this is cool. I'm glad they're doing this. They can at least show you, if nothing else, because putting the processor into the socket correctly, you have to unscrew the screws in the correct order. If you apply too much pressure or not enough pressure, the CPU won't seat correctly, and things like RAM or PCI Express devices won't work. Worse than that, I've actually seen people rip off the standoffs for the heatsink on the motherboard because of incorrect mounting pressure. So this is the part that you can absolutely screw up. Don't be above reading the manual or seeking out help if you need it. So ASUS is unique in that they have this module that they call DIMM.2, which is a vertical board that goes sort of here near the power connection on the front edge of the motherboard. And you can actually mount your NVMEs to that, but I'm just gonna put them on the motherboard. Remember when you're setting up your M.2 that there's a standoff and a screw. You might be able to install the screw without the standoff, but your M.2s should lay perfectly flat. There should be no mechanical stress on your M.2. We've got our on motherboard M.2 installed. We can replace our heat shield. Now, one thing that you want to do when setting up your heat shield is make sure that you've got your thermal pads plastic removed. This will help carry heat away from the M.2 onto the rest of the motherboard. All right, so let's talk for a second about memory. 64 cores on this monster platform. Obviously, it's going to be good with visual effects. We've done Linux benchmarking with things a lot more than visual effects, even like bioinformatics. One of the really interesting things, fast memory actually does make a fair bit of difference as long as you're doing more than just rendering. So we got the G-Skill Trident Z Neo. This is a 3200 kit, 128 gigs and 4 sticks. Fast.
Fast, yeah. I mean, there's faster, but at that capacity and whatnot, I mean, getting up to 3600 even, it's going to be a challenge.
CL 16, 18, 18,
Yeah.
38, that's pretty fast. All right, the next thing is setting up the block. So we've got the EK Velocity STR4D RGB. Ah, that lovely plastic noise.
Solid.
It comes with the Ectotherm. It's fine. It's fine. There's nothing wrong with it. It's fine. And the very important, please remove before use. Mirror finish. So basically, we're going to mount this there, and this is a combination of nickel plated copper, and then our fittings are going to screw in here, and this is going to clamp down and be really nice. But the first thing that's most important is what's your school of thought on thermal paste patterns?
For the couple Threadrippers I've touched, I generally do the X because you need a bit more.
Like a corner to corner X.
I don't go quite to the corner. We don't want it squeezing out the side.
So the next trick with these is tightening down corner to corner because you want even pressure as it smashes the thermal paste. So you don't want to tighten each opposite corner down all the way, but you know, you want to make sure that you're doing it about as evenly as possible. Next up is hooking up the power supply. Routing the cables, it's a little tedious, but doing a good job means that you're going to have that much better airflow inside your case. So radiators. What's the goal of a radiator? It's just dissipate heat, right?
Yeah.
But not all radiators are the same. What do you look for in a good radiator?
I mean, generally you want a decent thickness and enough airspace to cool the components you have. So we're dealing with that 64 core monster, so we're probably going a little overkill with
Dual 360s?
dual 360,
Well,
but
I think the longer term plan is to water cool those EVGA GPUs because the EVGA GPUs will really sing when you let them, I mean, over 2 gigahertz water cooling. That's what I have back at the shop, but yeah.
I have one of those for the Win 3s on air still, and it gets toasty.
So we've got our fans put on the radiator, and we've got our cabling, our RGB cabling, sort of roughly the way that we want it. Notice that I've been sort of careful. I marked the radiator so that I knew where the back of it was. And I've got the cabling so that I can route the cabling from the back. I mean, it would be unfortunate if the cabling were all on this side of the fan, right? I mean, you don't really want that. We also have enough fans to do a push-pull configuration, but there's not quite gonna be enough room to do that. It always is a lot of fun to do test fits with your stuff to make sure it fits together. So we've got the small rad in the top because the large radiator, it's not gonna work in the top. There's not enough room for the fans and the radiator. But at the bottom, we've got so much room for activities. It's not a problem, we can fit it there. And if we wanted to, we could also do away with the distribution block, but because we're gonna have the water-cooled GPUs in the future, it doesn't really make sense to do that. So the long-term plan, dual 360s, push-pull. We've also got our EVGA 2080 Ti triple slot cards. Now these cards are perfectly fine. These are great cards. Even if you're just gonna stick with air cooling, we are gonna do water cooling at some point. Not today, we're gonna hurry. We got a benchmark. I mean, this thing's getting ready to, it's out now. It's launching. We're just gonna skip the spinning rims for right now. So we're not gonna be able to do a push-pull configuration at the bottom. We gotta pop these fans out. But for water cooling, then these only take up one slot.
Yeah, I mean, with the block on there, you'd definitely be able to fit both sets of fans in there. Just unfortunate.
Just another reason that you need to work with microcenter on your build because they'll help you plan all this stuff.
Yeah, this is stuff that we'd either catch before we started building or catch in the act, and luckily we'd take care of you from that point on.
That is a brick-like card.
Yes, it is.
All right, let's get building. Any build like this, there's a wet part and a dry part. You ever make cookies before? It's like that. You put the wet ingredients together, you put the dry ingredients together. We've got the dry ingredients together. Now it's time for the wet ingredients. So we got our distribution block in here, and we're going to connect it directly to our CPU. I mean, 64 cores, liquid cooling for the CPU. That makes sense. We're not ready to hook up our GPUs just yet because this thing's launching. We got to get it out the door. So we're just going to hook it up directly with one cable, and we'll get some more fittings and other hookups later and use our distribution block properly. It's alive.
It's, yeah, after a lot of fun.
It's the reset button, remember?
Yeah.
Would you like to do the honors?
I would love to. Don't mess it up. Oh. Beautiful.
What a build.
What a build.
Now, thanks to early access from microcenter, we've got a full suite of benchmarks on the Level 1 website. The 64 cores, I mean, what can you even do with 64 cores? Well, the visual effects industry is going to be on its head. We're going to hear a lot more about Hollywood and rendering and all the cool movies and stuff. AMD's really been able to tout that, but there is also a use for programmers and DevOps. You look at things like the Linux kernel, it's about 20 seconds. It's really not much of a speed up over the 3970X, but for larger projects and things like integration testing, modifying Git, the version control system, to do Git bisect, but more than one at a time, so that you're running hundreds of VMs doing regression testing, lots of simultaneous compiles. Yeah, the 64 core shreds and stuff like that. Things like bioinformatics, again, depending on what you're doing. Our particular microcenter build also has CUDA, so you can use CUDA acceleration or CPU acceleration. Believe it or not, CPU acceleration is great for researchers that don't have regular data sets or even normalized data sets. That's better for CPUs than GPUs. We tested all of that with GrowMax, the performance. The only thing that's faster for GrowMax is a dual 64 core EPYC. But this single 64 core, because of the clock speed delta, is within spitting distance of 128 core, 256 thread EPYC server. And again, all of that is on the Level 1 website if you want to check it out and do the details. I'm sure we're going to have a couple other videos on this system and the benchmarks coming up in the next few days, but the full rundown's on the website. Basically, the short version is, if you have something that will scale to 64 cores, this scales well. It scales shockingly well. Most applications will scale at least a little bit. It's not like the 2990WX where we had, we were able to observe regressions from moving from 16 to 32 cores with some applications. So there was a strong, it's like, hey, I probably could use the 32 core for some things, but I don't want the stuff that can't use it to slow down. We don't have this on this CPU. Even though its max single core boost is about 4.3 gigahertz, it's just a hair slower, but real world, it's basically the same speed. Look at Geekbench, Geekbench is going to be a little bit faster. And on the Linux side, things like our BMW benchmark, Linux is going to be 30 seconds faster on the, over 30 seconds faster on the Classroom benchmark. So that's a 2 minute and 30 second render on Windows, same settings, same everything. On Linux, it's 1 minute 57 seconds. 30 second savings, that's pretty substantial. But that took Clear Linux and some tweaking on the Linux side because each different Linux distro has different performance characteristics. So even on Linux, 64 cores struggles a little bit across all the different distros and all the different settings that you might be running with a particular Linux distro. But if you put in the work and tune it, you can get that 40% plus performance uplift, assuming that your program will scale to 64 cores. Your problem is big enough for 64 cores. Garrett, we got the build put together.
Yes, we did.
We got the benchmarks done. Today's Friday. It's February 7th. We're launching the 64-core Threadripper today, right now.
Real exciting.
Somebody can actually walk into your microcenter and buy that.
Yep.
Or a 64-core boxed processor, which we've got around here somewhere.
Not in the box, but...
And we got the full benchmarks. Now, the 64-core CPU, as you might imagine, I mean, it's not a gaming CPU. You don't...
No.
Somebody's going to come in and it's like, hey, I've got a gaming computer I want to buy. And it does have dual 2080 Ti's, which is about the best you can get for gaming, but
Yeah.
64 cores, what do you do with that? Well, that's why I'm here. So we've done testing for GrowMax, we've done testing for biological sequence alignment, we've done testing for compiling programs, and of course visual effects. Visual effects is huge. You might have seen the video that we did with the 3970 Threadripper. We were using Adobe Premiere and another program called Render Garden.
Yeah.
And what Render Garden does is it'll take the job and split it up, and then you can keep all 32 cores busy. Well, we've also tested that on 64 cores, and it turns out it just scales all the way up. It's just, the 64 core is just, it's unreal. Now, our system here, it's got 128 gigs. I've tested both 64 gigs, 3600, 128 gigs, 3200, and 256 gigs at 2933, but I had a lot of trouble getting the 2933 to work properly. 2666 is what's supported, but 3200 with 128 gig, unless you really need the 256 gig, I don't know. If you need more than 256 gig, you can go epic.
Yeah, you can scale up there, but
Yeah. So, but dual 2080 Ti's. Did we ever figure out how much this would set somebody back?
a lot. I think it was roughly around 11 grand when we were adding it up.
$11,000 of computer and then some. Microcenter will be more than happy to help you get this put together. You don't have to be intimidated by all the 4,000 pins, and if you just do this, if you just breathe on it wrong, the socket is ruined. They'll be more than happy to help you put that together. But more importantly, if you're going to build, you know, an AM4, you know, like a B350 with like the 6 core, like the 1600 AF, that's you guys sell a lot of those.
Oh yeah, it's probably the highest selling processor right now.
So even if you're going to get a system like that, they're going to help you build it if you want them to help you build it, because it's better for them to help you build it and not mess it up than you mess it up. So thanks to Microcenter, I got the benchmarking in for 64 cores. It's 128 threads. It's just unreal. Now, of course, we're testing Linux. Windows is a little bit on the struggle bus with 64 cores and 128 threads, because it splits it up. It treats it into 2 processor groups. But we're going live with questions right after this, because we kind of did this a little beforehand, but a little bit live. So I've got to get back to the office so I can take your questions. I need to go to the nearest telecom rack so I can get back to the office.
Up the stairs and to the right.